Hey loudspeaker fans, earlier this year an end user told me that they had taken our 21-inch subwoofer with a 6-inch voice coil and connected it directly to 120 volt wall household electricity, and that it survived for like 8 hours, and that they were very impressed with how durable it was. And I thought to myself, wow, what an amazing thing to do, and that must have been very loud. But then I thought, in free air, it's kind of a best case scenario. The woofer's got a big impedance peak right around that frequency, 60 hertz, and it's cooling itself really well. There's lots of excursions, so it should be able to take actually a lot of power. I bet that's actually not so difficult, and maybe we could do it with a smaller woofer. So I built a sort of bad idea device that I showed in an earlier video that lets you take a loudspeaker, plug it to a wall, has a switch like 10 feet away so you don't set your house on fire. At least you can turn it off before you set your house on fire. And drove to Rational Acoustics in northeastern Connecticut to do some damage. So this is our setup. We've got this 10-inch woofer on a stand, and I've got a thermocouple on it so we can tell how hot it gets. Then we've got a couple of pieces of measurement equipment. We've got this calibrated mic running into Smart, taking SPL measurements, so we can see how much the SPL drops as the woofer heats up. And then I've also got an oscilloscope with a current monitor. Already it's got a pretty high impedance at 16 ohms. At 60 hertz, which is why I chose this particular speaker. But if it survives the first 30 seconds, it should survive more or less indefinitely, because it's gonna go into 6-8 dB of power compression and then just not be drawing enough current to overpower itself. I'm gonna throw the big switch. No. Ooh. Yeah, so that exploded, which is not what I was thinking, but didn't get very hot. Only got a little, like 10 degrees on it. So we're gonna take a look at the coil and see the failure mode. This is how professional loudspeaker people diagnose loudspeaker issues. Like, what could have happened? Well, it either got cooked or the suspension came apart. Suspension's fine. Well, it was fine. Oh, the coil totally came apart. You can see that. So it actually it overexcursed. It was an overexcursion problem, not a power problem. And so it overexcursed so hard that it banged the coil. The coil separated there, and that was the end of it. Lesson learned. No, I haven't learned anything. All right, we're gonna try this again. We got a new woofer. We've been heating it up for the last half an hour with this DC power supply, putting in 52-ish watts. And that's got the motor structure up to 56, 57 degrees Celsius, which is, about what you'd expect once you were getting towards limit. So it's nice and toasty now. I'm hoping once we give it the full shot of 120, it's not gonna explode, but we'll find out. We gotta switch really fast. So here we go. We're gonna pull this off. I'm gonna turn that off so I don't get, hurt. So the coil cools down really quickly, but the motor structure won't cool down quickly at all. And I am hoping it's starting to smell bad though. It's really dancing. Yeah, it's toasty. You can see the temperature's going down because of the forced air convection. It might be So right after that thing finally died, there was a huge thunderstorm that rolled in, so I didn't get to do a post-mortem until just now. But you can see the failure mode was this tinsel lead sparked so much against the other tinsel lead that it separated. Right, it's hard to show right there. Yeah, that's pretty black right there. You can see how much arcing there was. And then once I cut that, it has banged off the back plate plenty of times. This is pretty ragged. That little woofer beat the snot out of itself for more than 8 minutes. Standing next to it, the mic measured 116 dB pretty much the entire time. It didn't really drop at all until obviously the very end. I don't know if we didn't lose any power compression because we preheated it or what, but this coil has plenty of copper left on it. When a woofer coil comes out of like the 4-hour AES test, it's black. So there's no problem with power here. It could have taken more. It just ran completely out of excursion. So, of course, the question is, what does this tell us about what kind of power woofer can take once it's in a box, and there's an impedance minimum around 60 hertz? Well, that's a whole different ball of wax and something I'm going to go into in my next video.